Okay, this question is saying that a cricketer can throw a ball to a maximum horizontal distance of 100 meters. With the same speed, how much high above the ground can the cricketer throw the same ball? So, in projectile motion, we know that this cricketer can throw. We know the horizontal range R depends on the formula of R is u square sine 2 alpha by g. Now it depends, g is constant, and that is gravitational acceleration, and it depends on u and alpha. Now u is constant. Suppose the same speed, it is saying that he can throw maximum 100 meter, that is r max. R max is 100 meter, that is given in your question. So what is R max? That is, suppose speed is constant and alpha is varying. So speed is constant and speed is the cricketer's maximum speed in which he can throw the ball, and alpha is varying. So you know that sine theta can vary from -1 to 1. So sine 2 alpha will, the maximum value of sine 2 alpha can be 1. Sine 2 alpha max can be equal to 1. So R max will be, u square by g. So u square by g will be 100. That means u square will be 100 into g. Now in many questions it is also asked that for which value of the alpha the horizontal range will be maximum. This is also another MCQ question. So that we can found from here, that is sine 2 alpha equal to 1. That means 2 alpha is 90 degree, that is alpha will be 45 degree. So if you are throwing a ball, if you throw with angle 45 degree with horizontal, so you can see that if from horizontal this is 45 degree, then with vertical it will also be 45 degree. 45 plus 45 equal to 90. So if you throw the ball in 45 degree angle, then it will reach maximum horizontal range. Okay, so now what is saying in the second part, that if with the same speed u, if the cricketer throw the ball vertically upwards, then how much high the ball will reach? So we know at the highest point the velocity of ball becomes 0, and this is u, and we know u square is 100g. So we know the value of u, we know the value of v, and we know the value of a, acceleration, that is we know gravitational acceleration a is minus g here, and we have to find the height, that is your displacement, so s. So you have to find s. So when you have to find s and you know u, v and a, the best formula you can apply is v square equal to u square plus 2as. We know this formula in one dimensional motion, we studied it. So v square, v is 0, so 0 square will be 0, and u square we know 100g, a is minus g because gravitational is downwards, minus 2g into s, and s we have to find. So this will be your 2gs equal to 100g. So gg will be eliminated and s will be 50. So 50 meter is your answer. What this question is saying? This question is saying the top of a tower, from the top of a tower of a height 40 meter, there is a tower which length is 40 meter. Now a ball is projected upwards with a speed 20 meter per second and at an angle of 30 degree. Okay, so at an angle 30 degree the ball is projected this is the ground. Now it is saying find the ratio of total time taken by the ball to hit the ground. Suppose this is point A, so from this point to this point the total time taken to go from A to C and to its time of flight. Time of flight means to reach from A to B, the time taken to reach from A to B, that is time of flight, and time of flight we know that 2u sin alpha by g. Here u is 20, u is 20 meter per second, so 2 into 20, alpha is 30, so sin 30 is half by g, g is saying 10, so that is 2, 4, so this is 4 into sin 30 means half, so that is 2. And now we have to find the total time, and this total time you can find in two ways. First approach, we knew that vector equation of displacement is on one-dimensional cases we have seen S vector equal to u vector t plus half a vector t square. So here we know that projectile motion is two-dimensional motion, and projectile motion is two-dimensional motion is just combination of two one-dimensional motion if you split it into its components. So if you split the u vector as ux and uy, then this you can describe the projectile motion with with the combination of two one-dimensional motion. So where along x-axis there is no force acting, so ux will be constant, and along y-axis only gravitational force, that is a constant acceleration, is working. And we have studied the cases of constant acceleration in one dimension, so here we will deal with only y components. So it will be sy equal to uyt plus half uy t square. Ay is minus g because along y-axis gravitational is working and it is downwards. So now sy will be your 40, but you have to understand that from A to C, the displacement along y-axis is downwards, so this will be minus 40, or you can write it as 40 minus j cap. So uy will be 20 cos 30 degree, 20 sin 30 degree u sin alpha, that is 20 sin 30 degree t minus half g t square. So now 20 sin 30 degree means half, so this will and a vector was along j cap, so this will be also j cap and this will be also j cap, so j cap will be eliminated, and now this is minus 40 equal to 10t minus half, g is equal to 10, so this will be 5t square. Now you can rewrite it as 5t square minus 10t minus 40 equal to 0, that means t square minus 2t minus 8 equal to 0, that is t minus 4 into t plus 2, t square minus 4t plus 2t is minus 2t, and minus 8 equal to 0. That means, so now either t is equal to 4 or t equal to minus 2, but this is not acceptable. So this will be our result, because time cannot be negative. The a from A to C, the time taken for the particle cannot be negative, so it is t equal to 4. That means t is equal to 4, and we have to find t is to capital T, that is 4 is to 2, that means 2 is to 1. So this is our answer. We could find the value of t in another approach, second approach, that is, you know that if we studied in vertical motion that if we throw a particle vertically upwards with speed u, then it will, when it will hit the ground, it will have the same, if you throw the particle vertically upwards with speed u, when it will hit the ground, it will have same speed, but the direction will be opposite. So if at this point uy, along y-axis the value is uy, then here at point B it also be uy, but downwards, and here it is ux, and there is no force acting along x-axis, so there it also will be ux. Now if you just study y-axis motion from B to C, that will be, you know, is from B to C, this displacement will take now, and that will be, suppose we take the negative y-axis as positive, so that will be our s, that will be 40 equal to, now uy will be same as this value, so that will be 20 sine 30 degree t plus half gt square. Now g is plus because we took the negative y-axis as positive, so this will be half g t square. Now suppose this is say t1, because this is not the whole time, but this is just t1 is from B to C, and t was from A to C, and capital T was from A to B, these timings. So this t1 we will found 40 equal to 20 sine 30 is 10, 10 t1 plus g is 10, so this will be 5 t1 square. Again if you divide all by 5, then it will be 8 equal to 2 t1 plus t1 square, and that will be equal to t1 square plus 2 t1 minus 8 equal to 0. That means t1 t1 plus 4 into t1 minus 2 equal to 0, and there you can say that t1 will be 2, because t1 cannot be minus 4, so t1 equal to 2. That means if t1 is 2, then t is the whole time from A to C, so t will be t1 plus t, and t we know is 2, t1 is also 2, so 2 plus 2 it will be 4, so t is to t will be again 4 is to 2, that is 2 is to 1. This question will solve. Suppose there is saying that there is a tower which has height h, and we are throwing a ball of mass m horizontally with speed v from the top of the tower, and it will reach a distance x from the foot of the tower when it will hit the ground. Similarly, another mass of 2m, another body mass of 2m is thrown from the top of the tower horizontally with an unknown velocity that we considered here v2, and when it reached the ground it made a 2x distance from the foot of the tower. So now we have to find v2 in terms of v. Okay, so what we will do, first let's understand the problem. Suppose I have always told you that projectile motion is just combination of two one-dimensional motion. Projectile motion is two-dimensional motion. It is just combination of two one-dimensional motion. Suppose at t equal to t1, at time t1, the object is here at this point. That means vertically it comes this much way at t equal to t1, and horizontally it has gone this distance at t equal to t1. So horizontally the vt1 distance it will travel, x equal to vt1, this will along x axis and this is along y axis. So this is the height of the tower. So at t equal to t1 this will travel vt1, it will move constant velocity because along x axis there is no force, and at this point it has no velocity vertically. So it started from rest along y axis. So it is in a free fall along y axis. So at t equal to t1 this comes this way, this distance, and at the same time it travelled this distance. At t equal to capital T this comes x distance and fall along y axis h distance. So along y axis this motion is just a vertical motion, and we have studied vertical motion, and along x axis it is just a motion of constant velocity. So this x will be v into capital T, velocity into time, and this capital T will be the time, because when it will reach at this position it will travel h distance vertically and x distance horizontally. So x will be equal to vt and h will be, it started from 0, so we know s equal to ut plus half at square. So s is h here, the displacement, and u initial velocity is 0 plus half a is g, it is helping to come the particle to the ground. So it is this a, this acceleration is acting towards the displacement vector. Displacement vector is this, and this a is acting towards the displacement vector. So that is why here a will be plus g, t square. So from this you can find t, and it will be root 2h by g. For competitive exams you have to remember this formula, that if a particle is in a free fall and if you just drop a ball from height h, it will hit the ground. If it takes time t, then t will be root 2h by g. If you drop a ball from rest from the height h, then it will take the time to reach the ground, capital T equal to root 2h by g. You have to remember this for competitive exam purpose. So this capital T will be what? Root 2h by g. So here x will be v into t, so v into root 2h by g. Similarly, here this 2x distance at this point, when it will reach the ground, the x will be 2x here, and v we don't know, v is v2, the constant velocity. Here is also the ball is thrown horizontally, so there is no vertical component, so it is also in a free fall along y axis, so it will be root 2 into height is 2h by g. So now if you divide the equation 2 by equation 1, divide 2 by 1, you will get 2 equal to v2 by v into, divide this by this, you will get root 2. So from this you can find v2 is root 2 v. That means C is your answer. Okay, here time taken by the projectile to reach from point A to point B is given as t. So suppose here time is 0 and here time is t. So, and we have to find this distance A to B, AB distance. It is inclined with the horizontal at angle 30 degree, and initial velocity is making an angle with the horizontal axis at is 60 degree. Okay, so ux, the x component of the velocity will be u cos 60 degree, and that is cos 60 means half, so it will be u by 2. Okay, and we know that the horizontal component of the velocity is only responsible for the distance the particle will cover horizontally, because we have learned this that how to study projectile motion or two-dimensional motion by two independent one-dimensional motion. That means two-dimensional projectile motion is combination of two one-dimensional motion. We can break this u vector by its vertical and horizontal components, and then we can study the motion of the particle for those components explicitly. So here ux is only responsible for the horizontal distance covering. So at time t, horizontally it will reach the point C. The horizontal component of this distance will be AC. So AC is AB cos 30. Now we know that it will reach the distance AC will be ux along this x-axis, no force is working, so the ux will be constant, ux will remain constant. So at constant velocity and t time, it will reach the distance ux into t. That means AC we know AB cos 30. Cos 30 means root 3 by 2 will be equal to ux. Ux is u by 2 into t. 2 will be cancelled out. From that we can find AB, and it will be ut by root 3. So D is your answer. Okay, in this question the initial velocity is given, that is u vector is given, that is I cap plus 2j cap. So that means ux is 1 here and uy is 2. I have told you many times that a projectile motion at any point x comma y, we can always study, suppose this is u vector, the initial velocity, and this is alpha with horizontal x-axis. So the projectile motion is two-dimensional motion, and we can study this projectile motion or this two-dimensional motion by breaking this into components. It's rectangular components. If we break this initial vector u vector as uy and ux, then we can study this motion by studying the two independent one-dimensional motion. That is, we can consider this motion as the particle is moving horizontally with ux uniform velocity, because along x-axis there is no force, and along y-axis the particle is moving with initial speed y uy, and this is pure vertical motion. Okay, and the projectile motion is just combination of these two motions, and here this motion is acceleration is 0, x is 0, and here this motion have ay equal to minus g, because there is gravitational attraction towards earth, that is in negative y axis. Along negative y axis there is a gravitational force, so there will be a gravitational acceleration, so ay will be minus g. So if we know, we started the vertical motion, so we can analyze this motion, we can analyze this motion also. So we always can analyze a two-dimensional motion by breaking it into rectangular components, and we are expert at one-dimensional motion. So by studying these two independent one-dimensional motion, we can understand this two-dimensional motion. Now you see the at time t, if this is at this point x comma y, then x will be what? X will be ux into t, and what will be y coordinate? Y will be, we know s equal to, we know the formula of one-dimensional motion, s equal to ut plus half at square. In x along x-axis, s-axis ux into t, or a is equal to 0, that is ux into t, and along y-axis y will be the distance it will cover, y will be uy into t plus half ay t square, ay is minus 3 into t square. So here in my problem ux is 1, so x will be 1 into t, that is x equal to t, and y will be, uy is 2, so this will be 2t minus half, g is given as 10, so that is 10 into t square, so that means y is 2t minus 5t square, and we know t is equal to x here, so y will be 2x minus 5x square. So which option is the same with this? Option A is your correct answer here. Okay, this question is saying a projectile can have the same range r for two angles of projection. Okay, if you throw a body with speed u at angle alpha with horizontal axis, then it will reach, suppose say this horizontal range is r, capital R. Now it is saying that if you throw with the same speed but at another angle, then there is a particular angle in which if you throw, it will reach at the same point. That means the range will be same. Do you know what will be this angle? What will be this angle theta? You know what is the value of theta? We have studied it in a problem. Okay, the condition is if this is alpha from the horizontal, then this should be alpha from the vertical, then also it will reach at the same point. That means horizontal range will be same, because we know the formula of r is u square by g sine 2 alpha. Now if you put 90 degree minus alpha, if this is alpha, then theta is 90 degree minus alpha. So if you find u square by g sine 2 theta for this angle, then also it will become sine 2 90 degree minus alpha u square by g sine 2 90 degree minus alpha. So that will be your u square by g sine 180 degree minus 2 alpha. So that will be u square by g sine 2 alpha. So these two are, suppose say this is r1 and this is your r2, and r1 and r2 will be same. So now it is saying that if t1 is the time of flight in the t1 and t2, suppose this time of flight is t1 and this time of flight is t2, and we know time of flight's formula is 2u sine alpha by g. Now so t1 will be 2u sine alpha, because this is alpha angle, by g, and what will be your t2? T2 will be 2u sine theta by g. Sine theta is 90 degree minus alpha, so sine 90 degree minus alpha by g, that is 2u cos alpha by g. Now it is saying then the product of the two time of flight, so you have to find t1 into t2, that will be your 2u sine alpha by g into 2u cos alpha by g. So this will be your, okay, so this will be your 2u square by g square into 2 sine alpha cos alpha, 2 sine alpha cos alpha. So that will be u square by g square, 2 square by g square sine 2 alpha. Now we know that r is u square by g sine 2 alpha. So this will be your 2 by g into r. Okay, it is asking that t1 t2, so t1 t2 is equal to 2 by g into r, that means t1 t2 is proportional to r. So this is your correct answer. Okay, this question is saying, suppose you throw a ball with speed v0 at an angle theta. Now at the same time when you threw the ball, a man started running from this point with v0 by 2 constant speed. So the question is, will the person be able to catch the ball? That means before hitting the ground, this man has to be present at this point. So when this ball will hit the ground, then this man should be there, because this man is constantly moving. So this man has to be exactly at that position at that time when the ball will reach the ground. That is at t equal to capital T, that is time of flight, the man should be cover the distance r. R is the horizontal range and t is time of flight. This is time of flight and this is horizontal range. That means, and it will be same when this x component of this velocity, so this, the x component of this velocity will be equal to v0 by 2. Only in that condition the ball and the man will reach at the same time at the same point, and then the man will be able to catch the ball. So v naught x, the x component of this velocity will be v naught cos theta. That means v naught cos theta should be v naught by 2. Only in that condition the man will be able to catch the ball. So that means cos theta will be 1 by 2. So theta should be 60 degree. So yes, the man can catch the ball if the angle of projection is 60 degree. So this is your answer. Okay, this question is saying a particle is projected at an angle 60 degree. So this is 60 degree above horizontal with a speed of 10 meter per second. After some time, the direction of its velocity make an angle. Suppose at this point it makes an angle. So at any point, how you find the angle? You have to draw the tangent at this point. So at this point the angle is 30 degree. The speed of the particle at this instant. What will be the speed at this point? We have to find this speed. So we know u is equal to 10. So the horizontal component of it will be u cos 60 degree. And we know the horizontal component remains constant throughout the motion because there is no force acting along this horizontal axis. So from this condition we can say u cos 60 degree will be equal to v cos 30 degree because horizontal components of velocity remains always constant. So here horizontal component is v cos 30 degree. So these two must be equal. So from this condition you will get cos 60 means 1 by 2 and v cos 30 means root 3 by 2. 2 will be cancelled out and v will be your u by root 3 and u know u is what? U is 10. So this will be 10 by root 3. By root 3 is 10. So this is your answer D. Okay, in this question the u vector initial velocity is given and we have to find the horizontal range, that is r. So we know the horizontal range. Formula of r is u square by g sine 2 alpha, but we are given u vector, that is 6 I cap plus 8 j cap. We know it is ux I cap plus uy j cap, and we know ux means u cos alpha and uy means u sin alpha. So u cos alpha is 6 here and u sin alpha is 8 here. So now we know u square by g, we know sin 2 alpha means 2 sin alpha into cos alpha. That means we can write it as 2 by g u sin alpha into u cos alpha. So it will be 2. The value of g is given as 10. U sin alpha means 8 and u cos alpha means 6. So 48 by 5, and that will be 9.6 meter, and that is B is your correct answer. Okay, this question is saying a projectile has initially the same horizontal velocity as it would acquire if it had moved from rest with uniform acceleration of 3 meter per second square for 0.5 minutes. If the maximum height is reached by it is 80 meter, then angle of projection is. Okay, so they did not tell us what is the value of u directly, rather than they are saying that suppose a particle is moving starting from speed 0 and it is accelerating, a is 3 meter per second square and t is 0.5 minute. That means 0.5 means 1 by 2 into 60 seconds, so that is 30 seconds. Okay, so what will be the speed of this particle after 30 seconds? Initially at t equal to 0, its speed is 0. So what will be its speed after 30 seconds? So we know that v equal to u plus at. This is initial speed, so you can take it as u. So u plus at. Okay, this u and this u is not same. This is another motion. This is a straight line motion of a particle, and this is projectile motion. Okay, u means here initial speed. So we know the formula of one-dimensional motion, that is v equal to u plus at, where a is constant acceleration, and that is 3 here, u is 0 here, and t is 30. So what will be the v? 3 into 30, that is h is u square sine square alpha by 2g. Okay, so here u is 90, so 90 square, and h is given as 80 meter. Okay, alpha we don't know, so it is unknown, sine square alpha 2, g is 10 given here. So from this we have to find sine square alpha. Sine square alpha is 80 into 2 into 10 by 90 into 90. So here it will be 16 by 9 into 9. That means sine alpha will be 4 by 9. So that will be alpha will be sine inverse 4 by 9. So D is your correct answer.